First derivative test. Okay. The wave function defined of interval I and Fp continues at a critical point C in I. At a critical point C in I. Next, point 1. If f dash x changes its sign from positive to negative as x increases to C, that is f dash x greater than 0, every point sufficiently at every point sufficiently close to C and to the left of C, f dash x less than 0, every point should be close to the right of C. To C at the left of C and f dash x change less than 0 at every point sufficiently close to C, close to the right of C. Then C is the point of local maximum. So you take the curve C, C minus H, C plus H, f dash x greater than 0, f dash x less than 0, f dash C. Is equal to G. This is increasing and this is decreasing. See, this is C minus H and this is C plus H. So it increases and then decreases. So this is the position of a local maxima. So this indicates, let f be a function defined on interval I. Okay, this is defined over I. And f be continues at a critical point C and I. If f dash changes sign from positive to negative as x increases to C, that is f dash x greater than 0 at every point sufficiently close to C and the left of C, and f dash x less than 0 at every point sufficiently close to C and at the right of C. then C is a point of local maxima. This is the definition of a local maxima. Okay. So maxima minima means it is local maxima and local minima. If it is not local, there is other name that is called absolute maxima, absolute minima. That case is different. Okay, we'll discuss that case. So indirectly, local maxima and local minima. Maxima minima means local only. If it is not local, there is absolute. That is different. We'll be calling as global. Otherwise, that is next case we'll discuss. We'll include the endpoints also. Now we will not include the endpoints. Okay, this is about a local maxima. Next. Next. Next one. The way from different on open to I and FA contains critical point in C. If the average changes its sign from negative 2 to positive as x increases to C, that is f dash x less than 0 at every point sufficiently close into the left of C and f dash greater than 0, then figure will change this time. Point of local minima. Increasing and decreasing. Oh, reverse your table. Decreasing. Increasing. F dash A is equal to 0. C minus H. F dash S less than 0. F dash S greater than 0. This is about the local minima. Okay, this is about the local minima. Now, if it is as a null, there is a local minima, local maxima. Okay, there is no change of sign throughout its travel, either increasing case or decreasing case. Automatically, it is a point of inflection, or it's a neutral point, neither maxima nor minima. Note down, then we'll go for that. Next one. If f of x does not change its sign from as x into 3, note. Does not change its sign as x increases to 3. Through C, then what happens? C is neither a point of local maxima nor a point of local minima. In fact, such a point is called point of inflection. Such point C is called point of inflection. We'll see an example here. F dash C1 is equal to 0. Here f dash x greater than 0. Here f dash x less than 0. Next, C1, C2, f dash C2 is equal to 0. F dash x greater than 0. Point of non-differentiability and point of local maximum. C3. This is point of local maxima. Point of local minima. Point of non-differentiability and point of local maxima. Point of non-differentiability and point of local maxima. Next. Point of non-differentiability Point of local minima. This one is not. So here local maxima, abdax even 0, abdax into 0, local minima, and here you are getting fixed point, and it is not there because there is no increase and there is no decrease especially. But this is non-differentiability, it's a point. Okay, there is no curve, there is no point, fixed point. So this is non-differentiability but maximum point. Here also non-differentiability but minimum point, like that. Next, note. If C is a point of local maxima, then f of C is the local maximum value. Similarly, if C is the point of local minima, then f of C is the local minimum value. Of f. Here also of f. Next. Not Okay, noted? Yes. Yeah, right. Inner right. Next, method to find local maximum minimum by first derivative test. So steps we are finding now. Okay. Step one. Step one. Let the given function is f of x and find f dash x. Means differentiate f with respect to x. Next, step 1, 2. Okay. F dash x is equal to 0 by find a and b as points of local maxima or local minima being critical points. Okay. Third case. Step 3. Take the points A and B and check individually if x is equal to A and x is equal to B. Next, value of x, sin of f of x, sin of f dash x. Nature of point. Close to A and to the right of A. Okay, so greater than 0 and close to A and to the left of A less than 0. And now sin of dash x is change here. Sin of f dash x. Nature of point. Local maxima. Local left increasing local minimum. Yes. Next. Close to A and to the right of A less than 0 and to the left of A greater than 0. This is local maxima. Okay, as per the table, now step 4. Now find local maximum value or minimum value by putting x is equal to a and x is equal to b in f of x. Okay, as per a and b local maxima or minimum value. This is the no down. Good. Okay, next. If you get 2 or more critical points, then you have to use the number line. Okay. Note. If we get 2 or more critical points, then for making a post of 3z, then we can divide for more easiness of step 3. We can divide the real number line into intervals. And then check each of the interval as A, B, C, etc. lies in for local maxima or minimum. This is the case. If you get more than 2 points, then automatically what you will get? You divide the number line and then you can check it into each interval for the case of local maxima and local minima. Dividing the number line according to the ABC, the values. Example. Find the points of local maxima or minima for f of x is equal to x minus 1 whole cube into x plus 1 whole square. Okay, given f of x is equal to x minus 1 whole cube into x plus 1 whole square, f dash x is equal to x minus 1 whole cube into 2 into x plus 1 plus x plus 1 whole square into 3 into x minus 1 whole square. That implies x plus 1 into x minus 1 whole square, it equal 2 into x minus 1 plus 3 into x plus 1 is equal to 0. Implies x is equal to minus 1, x is equal to 1, 5x minus 2 plus 3. 5x plus 1 is equal to 0, x is equal to minus 1 by 5. So divide the number line by number line. Minus 1, 0 here 1, minus 1 by 5. Okay. Checking each case. So we have to check each case. Now divided by number line, minus 1 by 5, 1. Okay, this is 0. Now we can go here. So we make a tabulation. Value of x, sine of f dash x. Nature of f of x. Nature of point. Left to minus 1. Right to minus 1. So sine of f dash x. F dash x is equal to what we got? X minus 1 whole square into x plus 1 into 5x plus 1. So left to minus 1 is minus 2 you take. This is 9. 9 into minus 1 minus 9 minus 9 into minus 9. Also greater than 0. Close to minus 1. Greater than 0. Minus 1 by 5 you take. Or minus 1 by 2. Okay, minus 3 by 2 whole square, positive here, here positive, here negative, so less than 0. So automatically left is greater than 0, right is less than 0, so automatically local maxima. Next, close to minus 1 by 5. Left of minus 1 by 5, right of minus 1 by 5. Again, this is less than 0 and this is greater than 0. 0 you can take. Right. Now, local minima. Third case, close to 1, left of 1, right of 1. Okay, so what comes here? Left of 1 is 0 you take, greater than 0, and here right of 1 less than 0. Both are right of 1 also greater than 0, no? Okay, both are right. Here, neither local maxima nor local minimum. There are no change in sign. No. Local minima. No change in sign. Okay, so one local maximum point, one local minimum point, and one critical point you got. Point of inflection. That's why you do it. This is about the first derivative test to find the, because we have done the derivative only one time. Right? Now, if the function is viable for second derivative, we can go for second derivative test. We'll think of it. Because second derivative test we can go when the function is able to be done with the derivative for second derivative. It is viable or it doesn't extinct or it doesn't lapse. So second derivative test is there, that we'll discuss tomorrow. And examples also. Again, one more case, absolute maxima or global maxima, local minima is there. That also we'll discuss tomorrow. Recently your test on, I told you now, chapters probability, 3D, linear programming, vector algebra. Linear programming, vector algebra we did not discuss. You can discuss later also because already you know they are easy parts. 3D and vector algebra, 3D and probability we have discussed as revision. The next core and largest chapter is application of derivative that we are discussing now. Our integration part we are very recent to cover with. So calculus part revision is left for us now. 5 topics. And practicals also. That also we have to see. That is just writing only, not a big issue. Close to right side.